O2C1 Part 2, we will talk about solving quadratic equations. Before we get into the solving, we have to review the zero product property. This property says that for any real number a and b, when a and b are being multiplied together to equal 0, either a must be 0, b must be 0, or both must be 0. We can use this property to help us once we have something that's factored. So if you look at number 1 here, we have a quadratic that was already factored for us. I'm noticing that it's equal to 0, so we are going to solve. Now, based on that zero product property, I know that if this entire thing is equal to 0, then either one of these parentheses must be equal to 0. So I'm going to take each set of parentheses and set them equal to 0. From here, we're going to solve each of these equations. I'm going to start with this one. To get x by itself, I would add 1 over. So I have 2x equals 1. Dividing by 2 gives me one of my answers, x equals 1/2. The other little equation I have is just x plus 3 equals 0. This is a little bit easier, just have to subtract that 3 to get it over. And I have x equals -3. Go ahead and try number 2. Here's my work for number 2. If you got this question wrong, make sure you pause the video again and try and find your mistake. Don't freak out if you're getting fractions as answers. That is totally fine. This will happen quite often. The only other way we can make this problem a little bit trickier is to give you something that looks like number 3 or 4. Okay, our directions still tell us to solve, so we're still trying to figure out what x is equal to, but the big difference is this quadratic is not factored. So we are going to have to factor first, and then we can figure out what x is equal to. Now I know that in order to factor, I need this to be in standard form, and it needs to be equal to 0. It's not equal to 0 right now because of this -6, so I'm going to add that 6 over. I'm writing this in standard form, so I'm putting that 10x squared first, then the 16x. Now I have the plus 6 as my c value, and it's equal to 0. From here, when I'm factoring, I know that I should always be looking for a GCF. So between 10, 16, and 6, I know all of those can divide by 2. So I'm going to take out a GCF of 2. 10x squared divided by 2 gives me 5x squared. The 16x should become 8x. And 6 divided by 2 gives me 3. Alright, now I'm working with this little quadratic in my parentheses. So when I'm factoring, I always start with taking a times c. So 5 times 3. That means that I am going to be multiplying to 15. And the two numbers that I come up with should always be adding to my b value, so 8. Okay, so we're looking for two numbers that have to multiply to 15 and they have to add to 8. Hopefully you come up with 5 and 3. Okay, I'm going to start my factor by grouping here. I'm leaving that 5x squared, but now instead of the 8x, I'll put 5x and 3x, leaving the c value. Group our first two and our last two. Out of 5x and 5x, I believe I can take out a 5x. That should leave me with x and plus 1. Watch out there, when the 5x is divided by 5x, it is not 0. It does leave you with just a positive 1. Now I'm looking with my last two terms. 3x and 3 can both be divided by 3, so I'll take out 3. And again, I'm left with x plus 1. Okay, my common factor is that x plus 1. That's what they both have. And my next factor comes from those two outside pieces, so the 5x plus 3. Now that everything is factored, we can go ahead and do the same process that we saw in number 1 and 2, where I set every piece equal to 0. Now the GCF that we took out in the very beginning was 2, and this can be kind of a tricky part. If I took this 2 and I set it equal to 0, there's no x there, there's nothing to solve for, so I don't really need to worry about that GCF. Next up, I have the x plus 1. I'll set that equal to 0. To get x by itself, we would subtract 1. So one of my answers is x equals -1. The other factor was at 5x plus 3. I'll set that equal to 0. A little bit more work on this one. We'll start with subtracting that 3 over. And then finally, we'll divide by 5 to get x by itself. And we get -3/5. So my two answers here are x equals -3/5 and x equals -1. Go ahead and take a minute to try number 4. Watch out on this factoring. Since there's only 2 terms, your factoring may look a little bit different than we saw in number 3. Here's my work for number 4. Again, this was not in perfect standard form, so we had to move that 81 to the other side by subtraction. Then I'm left with x squared minus 81 equals 0. Only those 2 terms there. Hopefully you noticed this was a difference of 2 squares. The square root of x squared gives me x, and the square root of 81 gives me a -9 and a +9. From there, I set each set of parentheses equal to 0 and solve for x. We should get x equals 9 and x equals -9. Okay, let's take a look at number 5. Very similar. It says, what are the solutions to the equation below? And they give me this little quadratic. Whenever you see this and it's asking for solutions, this is another way of asking you to solve the equation. Now, I'm noticing that this is equal to 0, but it doesn't look like it's in perfect standard form. So I'm going to go ahead and move this around a little bit. I'm going to put the -121k squared first with the +100 after it. Now I know that a 100 is a perfect square, and I think 121 is a perfect square as well. It is, it gives me 11, but it looks like we're adding instead of subtracting. So in order to use a difference of squares, I need this to be a subtraction sign. So let's go ahead and divide this whole thing by -1. That GCF of -1 will hang out front. -121 now becomes +121k squared, and this +100 becomes -100. Okay, I'm focusing just on the inside of these parentheses here, and we're going to use our difference of squares. We just found that the square root of 121 was 11. So the first part of my factor should be 11k, and the square root of 100 is 10. So I'll have 11k minus 10 and 11k plus 10. A little bit trickier there with the 121 in front of your k squared. Okay, once we are factored, we can go ahead and set each parenthesis equal to 0. And we're going to solve. So I'm going to add that 10 over. So I get 11k equals 10. Dividing by 11, and one of my answers is 10 over 11. This guy I would subtract, so So I'd have 11k equals negative 10. Again, moving that 11 over by division. And so my k is negative 10 over 11. Looking at my multiple choice answers, it cannot be A or B. It looks like they forgot to square root the 121 and the 100. At first glance, C looks okay, but they only have the positive answer. They're missing the negative, so it cannot be C. So my final answer is D. Number 6 says, given 2x minus 3 and x plus 4 equals 0, let x equal A and x equals B be unique solutions to the equation above. What is the value of negative A minus B? Now, this one sounds very different than what we've looked at before. But what they're telling you here is that once we find these solutions, which we said was like solving, once I have my answers, one of your answers we will call A, and the other answer we will call B. Once I have my two answers, I can then plug them into this equation right here. Now it looks like the quadratic they gave us was already factored, so that's nice. I don't have to worry about the factoring part. So I'm just going to take each of those factors and set it equal to 0. From here, I'm going to solve. So I'm adding 3, dividing by 2. One of my answers is 3 over 2. This one, a little bit easier, just have to move that positive 4, so I subtract it, I get x equals negative 4. Now here's the new part in this problem. They told me that x equals A and x equals B were my solutions. I have my solutions here, so I'm going to call one of them A and one of them B. So A is 3 halves, B is negative 4. For my final answer, I want to find negative A minus B. So I'm going to plug in here. For A, we have 3 halves. And for B, we had negative 4. Let's go ahead and plug this into our calculator. So I have negative 3 halves minus negative 4. 2.5, I'm going to change this 2.5 into a fraction since one of my answers was a fraction by hitting math, enter for frac, and enter one more time. So it gives me a final answer of 5 over 2. Make sure you're reading carefully. A lot of times they'll ask you to solve the equation and then take your answers and do kind of one more thing with them. All right, number 7, our last problem. Again, gives me a quadratic. It looks like it's already factored and it's equal to 0. It says in the equation above, m is a constant. That means that m is just a number. It says if the equation has the solutions x equals negative 5 over 2 and x equals 3 halves, what is the value of m? Now I know that if I were to solve this, I would start with taking each of my parentheses and setting them equal to 0. Okay, this first one just has an x. I don't have any like random letter like m. So if I were to solve this like normal, I would subtract that 5, I would divide by 2, and I would get negative 5 over 2. So that's this answer that they told me. That one matches. Now this equation is a little bit trickier because there's two variables happening. There's an m and there's an x. But what's nice is they told me what x is. They said that x is 3 over 2. So let's go ahead and plug that 3 over 2 into x. And now my job is to get this m by itself. We're going to start with subtracting this 9. I'm going to rewrite this since this is negative m and 3 halves are all being multiplied together. And I'm going to write it as negative 3 halves times m. Now it should be equal to negative 9. You have a couple options once you have this fraction here. I personally like to get rid of the denominator. I don't like fractions, so I would multiply each side by the denominator, or the bottom of your fraction. On this left-hand side, the numerator and denominator cancel. Times 2 when divided by 2 are opposites, so I'm left with negative 3m. On this side, I have negative 9 times 2, which is negative 18. My last step then, divide by that negative 3, and m is equal to positive 6. So again, a little bit of a trickier problem. My recommendation is to write out your factors, figure out what you know. For example, they gave us the x here, and then you should be left with whatever you don't know, and you can solve from there.